webinar is an overview of optimization applications in Excel using Analytic Solver. I'm Dr. Sima Maliki and happy to present this webinar. During this presentation, if you have any questions or comments, please type them in the chat box to be answered at the end as time allows. During the Q&A, you are welcome to raise your hand and we will unmute you to speak. Today, we start with solving a refinery optimization application. We explore the cloud-based version of Analytic Solver and how to build a web page using Create App. I will show you how to quickly create a macro to automate the optimization process in Excel. Then we model and solve a manufacturing business problem using optimization. We conclude the webinar with a portfolio optimization problem and using parametric optimization to build an efficient frontier. You're probably aware of the increased interest in advanced analytics across many industries. We would like you to know that many of our customers have found optimal solutions for their large-scale industrial problems worth millions in savings. You can also learn to build analytic solutions in Excel and create greater business payoffs for your clients and better success for everyone, as building a model can give you insights and a money-saving optimal solution. So, what do you need to do when you want to use optimization and get some powerful business results? You have to be able to build some kind of a model that goes from the business situation in quantitative terms to a model that you can analyze and solve. Solvers or optimizers are software tools that help you determine the best way to allocate these resources. Your resources could be any scarce resource that arises in your business. For example, money, equipment, staff time, transportation fleet, or raw materials inventory. For example, you want to decide which products to ship from factories to warehouses along each route. Or in a portfolio optimization, you are allocating money to stocks in the portfolio. So now, what do you need to do to use a solver, or how to define your optimization model? There are three main steps. They are determining your optimization objective function, decision variables, and constraints. Now let's discuss each of them. Each optimization problem involves one or more decisions that must be made in order to solve the problem. You can approach them with a basic question. What factors are under our control? These decisions need to be made in the best possible way while simultaneously satisfying a number of logical conditions or constraints. Constraints can reflect physical situations. For example, non-negativity on variables. You cannot produce a negative number of products. You cannot assign a negative number of people to tasks. Some constraints are determined by policies that you or your organization may set. For example, in a portfolio optimization, you might have a limit on maximum percentage of funds to be invested in any one stock or one industry group. You might have balance constraints. For example, warehouses are temporary holding points. Therefore, flow out from one warehouse is equal to its flow in. They have a equality form. Another common element in each optimization problem is the existence of some goal or objective that the decision maker considers when deciding which course of action is best. You can determine objective function by asking, what measures are we trying to optimize? The best or optimal solution might mean maximizing your profits, minimizing costs, or achieving the best possible quality. Now let's start our first example. In this problem, their goal is to plan the operations of a refinery to maximize total profit. So let's open the Excel workbook. Here is the full analytic solver ribbon, which includes optimization, simulation, Monte Carlo simulation, and data mining, and also text mining. So in the analytic solver group tab, you get access to decision trees. And so there's three tabs when you install our products. Analytic solver will show up, data mining would show up, and solver home tab would show up. So let's take a look. The data mining group, you can perform data analysis, time series forecasting, and data mining. And you can also access the text mining. In the Solver Home tab, you can access the cloud-based version of Analytic Solver that is included in your desktop license. So let's erase all these drawings. So let's quickly walk through the ribbon. Clicking on this Model tab displays or hides the task pane in the right side. Then we have the simulation model group. I'm not going to spend time there because we're going to have a separate webinar for Monte Carlo simulation and stochastic optimization tomorrow. So the next one would be optimization model group. Here we have decisions, constraints, and objective, the three main components of each optimization problem. So we have decisions that are normal recourse. Recourse goes back to stochastic optimization. We have constraints, normal constraints when you want to define a constraint in your optimization. And we have variable type bounds. These are related to your decision variables. For example, in optimization, you can have decision variables to take any numbers. So just define them as decisions. You can give them, of course, bounds, like a decision variable takes values between this number and this number. You can define them as integer, binary, semi-continuous, all different, conic, and so on. We have the objective, minimization, and maximization. Parameters tab allows you to define parameterized optimization and simulation models. And we are going to discuss that today, how to use this tool. Simulate for running simulation, optimize for solving optimization problems. And then we have the Create App button. Create App button allows you to convert your Excel models to gives you all the things you need if you want to have a web application. So there are three different ways to actually run your model. You can create an app and have a web page that is self-contained that can be the basis for a web or mobile analytic app. So you can just go to create app web page. A new web page will open up. It's an HTML page. And as you can see, there are AJAX calls to our Raison server. And you can click on Quick Optimize. It will solve the optimization problem for you. If you right click and go to view page source, you can see that everything is translated for you in JSON, and your developers that are working for you, they would totally understand this language, and this makes it very easy for them that without knowing anything about their optimization, they can create your web application or mobile application. So this tool is available to you. It's just a few clicks, even not few, just one. It creates it for you. Now, if you want to learn more about this tool, you are welcome to go to raison.com. This is our RESTful Analytic Solver object notation. It is our modeling language in JSON, and it's a REST API that allows you to test, deploy analytic models using optimization, simulation, and data mining in web and mobile application. So to learn more, you can go to Try It page, and also there is a help tab that talks about different components of how to use the Raison. But the good news is you don't need to really program anything, just use these buttons. And if you want to use the Raison.com page, you could actually do that. So you click on that button, and it actually takes you to Try It page. Everything is translated for you. This is your model. Now you have the option to solve it here. And you have also the option to use any of the existing examples that are available for you. And from here, you can again click on create app and have an HTML page like just like the one that we created. So these are some of the really good features of Analytics Solver that allows you to go from Excel to your applications. You could also use Tableau or Power BI. You can create custom visuals for Power BI, for example. Just click create app Power BI, and then you just give it a name and click save. I've already done that, so let's go to Power BI. This is Power BI desktop version, and I can click on this buttons in the right side to import a custom visual. For example, for this one, I have the refinery. It successfully imports it, and then click on this icon to run the model. It's giving you all the variables and objective values. It's using the same Raison server and visualizing the outcomes for you. Now, the good news is you can actually change, mark some of the cells as input variables and input data, and then upload a file with your data in Power BI, and then run the model from Power BI with that new data and adjust parameters and get the results. So there's a lot you can do within this Create app when it comes to visualization, exporting the model, and having a web page or mobile pages, mobile applications. Next, you have the reports, charts. You can create decision trees. You can fit distributions. This is more into simulation. If you have historical data and you want to fit a distribution, that's what you use. You have the publish button for publishing the models for Excel Online and Google Sheets. Then you have load and save and get data. So let's see what is get data. Get data allows you to bring data into Excel, and you can do this many different ways. You can bring in a statistical representative of your data from another worksheet, different databases, Microsoft Access, SQL Server, Oracle, Power Pivot, and you could also bring this sample from big data. So if you have big data, this tool allows you to connect and bring your big data into Excel for use in your optimization and simulation models. Now we are using Apache Spark Big Data Clusters. I will show you quickly how we do this. In this dialog, you can select the data. For example, here we have 6 different big data, and I can, for example, just give the Boston housing. Some of them are 120 million rows of data, and they're spread across different hard disks. And when we are using this button, we're actually communicating through Amazon Web Services and bringing this data across all those computers, statistical representative sample of it to Excel. So you can go to options and decide how much you want to import, and then just click on run. So then you get the sample, and then it's ready for your further use. So let's go back to our refinery operation. You have different options, help that allows you to access all the examples. So if you want to learn about all the examples, shipping examples, just click on Analytic Solver options, actually help, and then examples. So if you want to learn more about optimization, just click on optimization examples, and different industry examples are available for you. From help, you could also access different user guides that are available to you if you want to learn more about optimization, more in-depth learning about our products and how to use it, and all of them are available in this main user guide. If you want to learn about different engines that are available to you to solve your optimization problems, click on user guide engine guides. Okay, now the right side, this right section is called task pane. If you look at our user guides or videos, this is what we call a task pane. Now it has model tab, platform tab, engine tab, output, and workflow. Workflow at the moment mainly used for data mining. Model tab shows your model in outline form. So as you can see, we have optimization, objective, variables, constraints, and then you have bounds. So this will show you where everything is. And here you can see I've used some name ranges. In the lower section, you can see that I have the size of my model and also what is the model type. So when you define your different components of your optimization problem, depending on the relationship and formulas you have, you will have a final optimization model structure. This structure, if it is everything in your model is a linear function of your decision variables, this would be an LP or linear programming optimization models. If you have nonlinear functions, for example, power or some other nonlinear operations, your model structure may come out as a nonlinear type model. Then we also have smooth and non-smooth. And for each of these optimization problem, there is a different engine that is appropriate to solve that optimization problem. Now, if you have this knowledge and you know the model, your model is linear, then you can go to this engine tab, select your desired engine, and actually you don't get all of this, you just get the standards with Analytic solver. But I wanted to show you that we actually have a larger scale engine package and some other famous engines out there that are available to you if you would like to use them. So if you know the structure of your optimization model, you can select one of these engines and solve it. If you don't know the structure of your optimization model, no worries. We have ways to actually help you find out what is the structure that you have defined and then what's the proper engine to use to solve this optimization problem. And I'm going to show that to you in a few seconds. So we talked about this. Uh, so each engine, when you select it, there's a bunch of options down here that you can adjust. And then we have the platform tab. These are some generalized platform options that you can adjust in the models. It's not specific to each engine and it just applies to everything. And then output tab that you get a report of solution message. And if there's an error, you will get it here. So for this optimization problem, imagine we didn't know it's a linear programming convex model. So I'm just going to use options, operating mode, guided mode. And when you install Analytic Solver, the default setting is on guided mode. So you don't need to really do anything. So let's click on optimize on the ribbon to solve this optimization problem. This is guided mode. It is a step-by-step help that gives you different dialogues, and in each dialogue there is information about your optimization model. So this is really helpful to give you more information about what you have developed. So let's click on continue to see what it tells us. Two things happen here. First, this model was analyzed as LP convex. So I now know that my optimization model is linear programming convex, which is really good. It's a good news. Now, there's some information of what this means. Linear programming models are the easiest to solve. Usually you can get a proven optimal solution. Now, there's a problem here. For solving a linear problem, you have to use an appropriate engine, which is standard LP quadratic engine when you just have the basic engines. Now, if you have larger scale engines, you have other options such as Gurobi, Express, larger scale LP solver. So you can select the proper engine. So you can see it is telling me that my choice is not recommended. Let's clear the warnings. So let's select the correct choice, which is a linear engine, and then click on next step. Now it gives me the results. Solver found the solution. All constraints and optimality conditions are satisfied. Now I click OK, and we get the optimal solution. In the task pane output tab, you get a report of how long did it take to solve this optimization problem, what engine was used, and a green message. Sometimes this is red. Don't worry, if you get a message that you don't understand, just click on it and it will open a help tab for you. And in the help, you get some information about what does that message mean. Okay, let's go back to this model. So far we have used the solver to solve this optimization problem. If you select an engine by mistake that is not appropriate, the guided mode can help us correct that. Another option is to go to Engine tab, and there is this button, automatically select an engine. And you can always check this button. And if you do that, it will select the right engine for your model type. Now let's talk about the cloud-based version of Analytic Solver. So the models in Excel can be uploaded. If you click on Solver Home tab, you can upload your models to a cloud-based version. So you can select the model and upload it. I've already uploaded a few of the models, refinery operations and so on. Then you can go to Analytic Solver and log in with the same username password that you have used to um, create your Excel or Solver account. So then go to Analytics Solver. So I'll just log in and then click on Analytics Solver. It will load, and in a few seconds you will see that this ribbon, it would be exactly similar to what you would see in Excel. So very similar. All the tools that you have in Excel, you will have in the cloud-based version. And what this does is allows you to run your optimization models anywhere from your browser. So you uploaded the model and then go to Solver Home tab, and you can open models from your Analytics Solver account and load them. And then you can actually, this is the optimization model, the refinery optimization, and then similarly, you can go to Analytics Solver tab and solve the model. So this is another feature that is available to you that's I would like you to be aware of. So let's close this, go back to Excel. Now, as I promised, I wanted to show you that how quickly you can convert this Excel model to automate this optimization process in Excel. So let's first turn off the guided mode. Make it auto help mode. There's also expert mode. Auto help mode is good because it just eliminates the help and just shows you the help when there's a problem. Let's go to standard LP quadratic engine. So let's select the right engine. Now, our products work with both traditional VBA and standard and object-oriented VBA. So with object-oriented VBA, you will access the latest engines and all the features that you choose much faster. So try to use that if you want to automate or create a dashboard or so on. So to create a macro, let's just click on insert. I'm going to create a little button. Now you can right click and assign a macro to this button. Let's create a new macro. Now we have Visual Basic for that assigns that the macro to our optimization model. First thing we want to do is click on Tools, References, and set a reference to Analytic Solver Type Library, and click OK. Now, to automate the optimization process, you just need a few lines of code. First, you have to tell, first create an instance of your optimization problem. So type in dim prop as new problem. So you can see I get intelligence prompts, and then prop So now I have a problem dot solver dot optimize. So this is all you need to optimize your the model we have. Now, there are many reports that are available to us, and you can explore these reports. For example, an answer, sensitivity, limit reports are all available when solver finds a solution for your model, and they give you additional information about the solution and its range of applicability. So let's get an answer report. Let's type prop.solver.report, and then answer report. So now we have everything we want. We want to get answers, first solve the optimization problem and then get an answer report. So I'm going to close this and I will go to output tab, clear the output window. So you will see that it will run the model. We get the result and we also have an answer report. Here's the answer report for us. Decision variables, the original and final values, and then different constraints. Which ones are binding, which ones are not binding, and more useful information. So this is all I wanted to share you with this optimization model. The next example, we want to define an optimization model from scratch. So let's move on to our next example. Have you been faced with planning or coordinating your supply and demand operations? For example, you want to select vendors, suppliers to minimize your total costs. In this example, we model and solve a supplier selection and routing problem. So let's open this example. Let's go to Analytic Solver. So we have a manufacturer with 4 plants that all require a center amount of a product. And they can purchase this product from different companies 1 to 5, and with different price per ton. Our goal is to determine the optimal selection of suppliers for each plant to minimize the purchase and distribution costs. So, what is the factor that is under our control? It is the purchase amount from each company for each of the plants. So decision variables are the purchase amount for each company from each plant, for each plant from each company. Now, you can have like a block of cells because we need one for each of the purchase amounts. And I have already done that. So let's make this black. So I have plant 1 to 4 and I have it under here. So it's under company 1 to 5. So this whole block, I have one cell for one purchase amount. So I have all this block and I want to define this as my decision variable. So you can just select this block, go to Analytic Solver and define it as decision normal. So you can see that C16 to G19 is defined as a block of decision variables. So this is how you define decision variables in Analytic Solver. Now, if you wanted to, for example, select these 2 cells and define them as decision variables and you wanted to have a name for it, you can just give it a name, for example, var, and then define them as decision normal. And then you can see that the solver recognizes the Excel name range and uses var in the model instead of the range H2 to I2. So let's get rid of this additional variable group. So now we have the decision variables. And then we have to define our objective. We want to calculate the total purchase and shipping cost and then tell solver to minimize that cost for us. So let's first calculate this cost in the model by using all the information we have. So I can have a sum under company 1 for whatever we purchase for plants 1 through 4, all the way to company 5. This is on my total purchase for each from each company. Then we have additional information that we need. Now, there is some more information in this problem. There are inputs to the problem. One is available supply. Each company has a certain supply available, so we can't just buy everything from one company. And there is a demand for each of the plants. So we want to at least satisfy our demand. Those would be our constraints. So let's work on our objective. So we have a total, and then we can calculate cost of product. We know that the price per ton for company 1 is 40. So we can just multiply 40 by total that's going to be bought from company 1. And this can be continued all the way to company 5. And then, of course, we can add them all together. So this is our total cost of products purchasing. Now, let's calculate cost of shipping. So we have this distribution costs for each company, 2 different plants, and to calculate, you can use a sum product function. So instead of multiplying this cell by this plus next one multiplied by this one, sum product just does that for us. So just use a sum product. First array would be this block and second array would be this block, or vice versa. And we add them all together. This is our total cost of shipping. And then under this, we can add total cost of product and total cost of shipping. And this would be our total cost that we want to minimize. So let's select this cell H25. It has a formula that calculates our total cost or our goal or objective. What is our measure to be optimized here? We want to minimize the total cost of shipping and products purchased. And so we add them all together. There's actually 2 functions now. There's the cost of product and cost of shipping. So you define one cell as your objective function, but in that cell you can have many functions. So select that cell and let's tell solver that this is our objective, contains a formula that needs to be minimized. So minimize and normal. And now under objective in the right side in the task pane, we can verify that we have done it correctly. H25 to be minimized. So now we have to define the constraints. What restrictions limit our choice of decision variables? So the first group of restrictions is available supply from each company. So we want to make sure our totals are less than or equal to available supply. So let's select the block of totals. This is how you define a constraint in Analytic Solver. So select your block of formulas where you calculate the totals and then click on constraints, normal. And what we want to do is we want to make sure this is less than or equal to. So this is an add constraint dialog. We have these formulas in the left and there's a logic less than or greater than or equal everything. And you can always change it here. And in the right side, I want to say, what is my right side? And this is the available supply. So in add constraint dialog, there's a left-hand side and there's a right-hand side. And you might have heard this term. So this is our left-hand side. This is terms that are used in optimization. And this is our right-hand side. It's the best practice to keep all your formulas in this side and the constants in this side. So let's click OK to add this constraint. Now we want to make sure our demand is satisfied. So first we have to calculate the total purchase amounts for plant 1 all the way to plant 4. So we just have this sum function. Let me show the formulas. So I have a total sum for plant 1 all the way to plant 4, whatever is shipped from each company to that plant. And we want to make sure this is at least equal to the demand. So let's go to Analytic Solver, constraints, normal, greater than or equal to, and in the right side, you can put the demand. And click OK. So it seems that we have defined what we needed. So now let's go ahead and click on optimize. If we notice that we have missed something, we will get a red message and then we can fix everything. So let's click on optimize. So This is the message that we're getting. This is guided mode and it's telling me the objective cell values do not converge. If you want to learn more, you can click and get some information. This means solver is able to decrease without any limits in the objective. And this problem is because I did not add I did not tell solver that my decision variables can only take positive values. So solver sees that it can, for example, get a negative value here and reduces the cost as much as possible because negative values are better than zeros. So it's really important in each stage to pay attention to the messages you get and then go back to your model and say, okay, this is what I need to do. I need to tell solver these variables need to take positive values. So to do that, there are two ways to do this. First, you can select this block, go to constraints, variable type bound, and let's set the lower bound of 0. So everything should be greater than 0 and click OK. Since this is such a common occurrence, we have a shortcut for it. So if you just go to standard LP quadratic engine, and then there's assume non-negative option here, and you can set it to true from false. So there's two ways to do this: assume non-negative option or just add a lower bound. So now let's try this again. Let's put the operating mode back on guided mode. So the auto help mode will only bring up the dialog when there's a problem, and we just saw how this helped us. So let's go to optimize. Let's use the guided mode. This is the LP convex model, and we get the optimal solution. This is the routing plan, how much to purchase from each company for each plant, and this is the total. Now, just if you forget, for example, to add these constraints on demand or like total available from each company, it's possible that we get a better solution because we are kind of limiting the routing. So let's click on optimize. Just remember this one was 74,690, and we get the optimal solution. And this is smaller because we are just allowed to ship as much as we want from each company. So you can see that everything is being shipped from company 1 and company 5, and we are not getting anything from companies 2, 3, 4. And this could be because of the higher purchasing price from these companies. So there is so much. You can explore the constraints. You can see what would happen if you activate or deactivate the constraints. So you can check them, uncheck them, and run the model. So this is it, how you want to define your optimization model in Excel using Analytic Solver. Now, there are more advanced features. We have a few minutes left. So let's move on to our last example for today, which is the stock portfolio optimization model. It's already defined, but I'm going to quickly walk you through this model. We have different choices of stock, and we are trying to minimize the risk and get a certain return for this portfolio. So this is about an investor who wants to target a specific rate of return for his portfolio while minimizing risk. So this is called a portfolio optimization application, and our goal is to find the best combination of stocks that minimizes risk for a given return. So here is the model, and if we solve this optimization problem, you can see that this is called QP convex, and the reason is we have the objective function in this model. It's portfolio variance calculated in this cell, and you can see it's a custom quad product function, and that makes the model quadratic. And then we are calculating the return here, and this is the list of portfolio options we have, and then variance and covariance of stocks. So these are our decision variables. Now, so far, what the model does is we used the solver and found the optimal portfolio with minimum variance for a given target rate of return of 9.5%. So if you look, I'm calculating the return, and then I have a 9.5% return. Now, imagine you want to generalize that and find the efficient frontier, meaning that you want to find the optimal solution for several levels of portfolio return. To do that, you can sit there and manually change this value, record them, and get the result, or you can use some of the advanced features of Analytic Solver. This one is called parametric optimization. So I want to define a parametric return rate. So let's click on parameter, insert an optimization parameter. And let's define it from a lower bound of, let's see, 8% to an upper bound of 14%. And click OK. Now we need to use this in our optimization model. So in our portfolio return constraint, instead of the constant value of 9.5%, I can point to, sorry about that, I'm going to point to this cell. So D20, our parametric return rate. So I use the parameter in the optimization. Now, if I click on optimize, I'll just be running one optimization problem, but I want to run, for example, 10 optimizations. So I go to platform tab, and the first option is optimizations to run. This is the number of optimizations to run. So from instead of one, we can run 10. So we are ready. Let's click on optimize. And I'm going to skip guidance and show you that we just finished running 10 optimization problems. This is the results for optimization number 10. You can explore and look at any of individual optimizations by looking at this optimization dropdown. So let's go optimization 10, optimization 1, 2. You can see the return value for that optimization, the portfolio, and the variance. And you can try all of them. You can get a report and get the results for all of this, or you can get a chart. For example, let's go to chart, multiple optimizations, monitored cells. Let's look at the objective. I click OK. And this is our efficient frontier chart. On the X coordinate, we see the optimization index, and on the Y coordinate, we see the portfolio variance. I actually like to see some more different information on X coordinate, for example, the return threshold, and you can do that by going to chart options and change the X coordinate to PSI optparam. And this is what you get. So we get the return threshold on X coordinate. Okay. We looked at these examples. This is a summary of how to set up optimization models in Excel using Analytic Solver. If you're interested, I can send you these slides. This is the whole picture for what Analytic Solver can do. Today, we just focused on using Analytic Solver for solving traditional conventional optimization models. You can use it for Monte Carlo simulation, stochastic optimization. These two parts we will discuss tomorrow. And on Friday, we have a webinar to discuss forecasting, data mining, and text mining. I have shared the links for registrations to these webinars in the chat box. Feel free to register for these webinars and join us. You're welcome to do that. So, but the good news is you are not limited to our Excel products. If you're interested to have a desktop or server application, you can use our SDK. For web applications, you can use SDK plus our Raison REST API. So our product lines provides you with a wide variety of options depending on the type of applications you would have. Many of our customers have found optimal solutions for their large-scale industrial problems worth millions in savings. And we saw today how building a model can give you insights as well as a money-saving optimal solution. So we have tools to help you get better solution by automatically diagnosing model structure, fixing problems for you, selecting the right engine, and provide you with updated information at each step. Today, we explored a few of those features. One of them was the guided mode that helped us choose the right engine. So if you haven't done this, download the trial version. And during this time, you have full technical support. You can email me at consulting@solver.com. And if you have specific questions about your project needs, and if you have a model that you would like us to take a look at, You can look at different tutorials, go to solver.com, download the example, and look at the examples, and always you're welcome to contact us at this specific number for the webinar attendees. Thank you very much. Now it's time for your questions. I trust this webinar was helpful. I really enjoyed presenting it for you, and you're welcome to provide us with your feedbacks. You'll receive a survey link. We really appreciate if you provide us with your feedback. So if you have any questions, you can raise your hands or type them in the chat box, the question box. Okay, thank you very much. Have a wonderful rest of the day, and I hope to see you tomorrow. Bye-bye.